Hey, good morning, guys. Um, so um I sent you guys all an actual invitation to join this call. So if you'd like to do that and you get the invitation, I'm not exactly sure how it works, but you can do that if you would like. And I also last night sent out at I think at 7. I sent out an office hours um, or Google Doc so that you guys could go on there and let me know what you'd like me to review today because I didn't plan for a problem set. I know you have a midterm coming up, and so you probably want to go over some of those things. And so I plan to just let you guys kind of. I didn't plan any material for this time. I just wanted you guys to kind of let me know what you want to cover. And I don't think I have any responses in there. I'm not sure if it's because I sent it out just yesterday evening or if it's because there was a problem with you guys like having access or anything. So I'll just keep an eye out on my email if you want to email in questions, or again, if you get the invitation to this actual call, you can join in that way as well. I'm going to send out this YouTube link real quick for you guys. Okay, so it looks like I have a couple of requests in now from the Excel sheet. You can also, the Excel sheet is probably the best way to ask questions, but you can also email in if there's something specific you want me to cover that doesn't appear in a problem set. But if it does appear in a problem set, please just put it on the Google Excel sheet in kind of the order that you guys asked the questions. So right now we have 2 in there. So I have a request for problem set 8 review 1 and problem set 8 review 2. So I'm going to open up the material for those and work through them with you because I didn't look at those problems yet. So I'll just open up my files. Okay, so problem set 8. Let's see here. Okay, so review question 1. Identify 2 externalities that you are aware of in your community, 1 positive and 1 negative. What policy proposals might you recommend to correct these externalities? So I'm going to open up lecture 8, because I think it's from that one. Maybe not. Okay, so I didn't find it in the lecture, so I just Googled externality, and I'm looking it up on Wikipedia for just to review for the definition. So it says, the first sentence says, in economics, an externality is the cost or benefit that affects a party who did not choose to incur that cost or benefit. And an example that it gives is air pollution or light pollution, or things that are byproducts of an economic activity that people have to pay, even though they may or may not be participating in the consumption of that product. So 2 externalities that could happen in your community. Let me think about this for a second. I mean, so one really easy one is always air pollution. And an example of how you could correct that would be to institute a policy that, so an externality, let me go back for a second and talk about externalities again. So when you have an externality, it's almost as if you have 2 marginal cost curves. You have a marginal cost curve that some private entity feels, and you have a social marginal cost curve that is higher. So there's like a higher social cost, but the private producers, if there's not some kind of market correction, they will just produce whatever is best for them at the expense of the community. So here's a marginal cost curve for a private company, and here's a marginal cost curve of society, and here's the marginal benefit curve of the producer. Okay, so when you have a negative externality for, say you're the executive of a semi-truck company, and so your job is to transfer goods from one location to another. It's going to be, it's going to cost you something to do that, but you might not take into account, if you're just thinking about yourself, you're not taking into account all of the pollution that that's causing. And so while your marginal cost curve is here, there's an additional cost to other people that is equal to some amount that society is paying on your behalf for your production of your goods. And that's a negative externality. You're not taking into account the full cost of the service when you are only thinking about yourself and not about the social implications. And so that's just like kind of the idea of an externality. And this is, so in this case, here's the semi-truck company. Here is the cost of additional cost to society that is being incurred. And so if you're taking into account this person and society, then you get this marginal cost curve, which makes it so that you're producing less of it, and there's a greater cost. So that's kind of how those work. Besides that, you just need to come up with examples for other externalities in your community, which would maybe just take me a minute. Let's see. So climate change, water pollution. Pollution is just a big one, no matter whether it's air or noise or light or any of that. There could be, if you think back to the recession and the cause of the recession, there is systematic risk. So that's like the risks that the overall community takes on as a result of risks that the bank is taking on. Let's see here. So there are others, but then you just have to get creative in terms of coming up with a policy solution that would raise that marginal cost curve to the social cost curve. Usually it's by adding a tax to the company that you, so it'd be adding, if you added a tax that would be equal to this amount, then you would take this marginal cost curve of a private company to the marginal cost curve of a social company, and it would fix that negative externality, because then society would be getting some of the value, or they would be getting the value back that they're contributing somewhat involuntarily. So I also had a request for question 2 on the review, so I will go down to that now. It says, suppose a landowner has a parcel of land that he rents out to farmers in the community. The landowner will not rent the land for anything less than $9,000 per year. If no farmer is willing to pay that amount, the parcel of land will remain fallow. This year, the landowner was able to rent the land for $12,500. Okay. I don't know what the word fallow means, so I have to check that. Okay, so it will remain plowed but left unsown for a period in order to restore its fertility as a part of crop rotation or to avoid surplus production. So according to the definition, it says that it's a piece of, so when land is left fallow, it is plowed and harrowed, but it's not sown. You don't put seeds in for a certain period in order to restore its fertility. So there's some value in doing that. And from this, there's value in restoring the fertility of the land. Maybe you get more production out of it the following year if you do so. And so I'm going to assume that because he won't rent for less than $9,000 per year, that must be the value that he places on keeping the land fallow and giving it the opportunity to return to fertility, the soil and all of that. So this is my assumption. Because he won't rent the land for anything less than $9,000, I'm going to assume, like I said before, that leaving the land fallow for a year is worth $9,000 to the farmer. He thinks that if he can sow there next year after having left it fallow for a year, that it's worth $9,000 in extra production to him, is what I'm saying. So $9,000, leave it fallow. And this year he was able to rent it for $12,500. Okay, the first thing we're supposed to do is define the principle of economic rent. That's really easy. We can find it in the slides. Economic rent is the value, the profit that you receive from, let me just look up how exactly it's worded in your slides, just so I don't drag anyone off. Okay, so I don't remember which slide set it's in, so I'm just going to talk about it instead. So economic, actually, let me see here. Okay, so economic rent is any payment to a factor of production in excess of the cost needed to bring that factor into production. Okay. Okay, so economic rent is any payment made or benefit received for non-produced units, such as land. So in this example, I would think that the economic rent would be $12,500, because that's the benefit being received for this piece of land, which is not a produced unit. It's just there. Actually, I wonder, let me just see 1 second. Okay, so let's see here. So what is the landowner's economic rent for this parcel of land for this year? I think it's $12,500. But I can't find economic rent in the slide, so I can't see the examples that he gives. Of course, I guess it could be the difference between 12,500 and 9,000, his reservation price. I'm gonna keep searching for this in the slides real quick. Okay, this is much better, so I'm glad that I found it in the slides. The definition of economic rents is the part of the payment for a factor of production, in this case land, that exceeds the owner's reservation price. Okay. Another thing he says about it is it's the extra monetary benefit you get for having something valuable because it is not easily replicated. Economic profit that can't be driven to zero by competition because people can't replicate it. So you can't, there's only so much land, you can't necessarily just come up, you can't just create more of it just because more of it is demanded or you would like to get into the market. And so, so in this case, it would be the difference between the $12,500, the rent that he receives, and his reservation price, which is here. So it's 3,500. Okay. Next part of the question. Let me see. Part C says, now suppose that during the next year, the landowner's reservation price has remained the same, but he now has several farmers that are willing to use his land. If the landowner takes the highest price offered at $14,500, what will his economic rent be for the year? In that case, it would be $14,500 minus his reservation price, which is $9,000. So $5,500. Okay, so that's 1 and 2. Let me see now on the Google spreadsheet if there are any more questions that have come up. Okay, I don't see any more questions, guys. It looks like I only have one viewer right now, and I'm assuming that that is the person that asked me these 2 questions that I just went over. I'm still here though, so if you want to come in and ask me any additional questions as you guys get online or anything. You just have somebody join the call. Hey, Bryce.
Hey, can you hear me?
Yeah, I can. So I have, it looks, I don't know if you're my only viewer or if there's one more online, but what I'm doing right now is just taking questions because I want to do a review session for you guys since the midterm's coming up. So if you have any questions, feel free to ask me. I've already gone over all the questions that we've had so far, so yeah, it's just kind of up to you guys. If you have a question, I'll start doing stuff again.
Great. I'm still I'm pulling out my old problem sets here. So
Okay, yeah.
There's certainly items I'd like to review. I don't know if there's questions other than, hey, can we review, I don't know, certain principles or whatever.
Yeah, once you find a question you'd like me to go over.
So on the problem set 3, could we review the whole Del Taco Buoy Guana problem? It's actually the first one on that problem set.
Sure. Problems. Okay. Problem set 3 and number 1. Okay. So buy meals, taco or the blue iguana. You're indifferent between these bundles. 6, 6, 3, 15, 2. So I'll graph. And so okay, graph the 3 bundles. So there's not back on nice. Have like another question to ask me at all, you can like, turn it off and then.
Yeah. I think your sound, it's probably actually my Wi-Fi connection, but your sound is cutting in and out. Probably because I've got a slow connection, and I might try switching over to a different.
Am I sounding choppy or am I sounding quiet?
It just cuts out. When I hear you great, and then it cuts out, and I'm catching, I'm catching like half sentences, but.
So I'm actually on Ethernet, so I don't think I should be cutting out because I'm just like.
Right, it's me. It's me. It's my Wi-Fi. I know it is. So I'm gonna switch actually to another one.
Okay, so I'm going to go ahead and draw this. We have meals in the blue one on this card. And then we go to the top. Okay, let's see. Let me open up the. No.
I got a phone call from you. Just.
Okay, so let me go back to the problem set real quick. So when given the option between 2 Del Tacos and 6 blue iguanas, okay, so I'm just going to go by 2, so 2, 4, 6, 10, 12, 14, 16, 2, 4. Okay, so given the option between 2 Del Tacos and 6 blue iguanas, or 6 Del Tacos and 3 blue iguanas, or 15 Del Tacos and 2 blue iguanas. Welcome. I'm just taking random review questions from people. And many helps. Okay, so these are the different allocations of meals that we are indifferent between. So having a few of those, we can draw an indifference curve. So I'm just going to assume that it curves kind of like that. So any point on this curve, even if this was a true indifference curve, I just kind of sketched it based on those three dots, but wherever the true indifference curve is, it crosses through these 3 points, and any other point on this line is also another point at which the consumer would be indifferent to any of these decisions. If you offer him 2 Del Taco meals and 6 blue iguanas, or if you offer him 15 Del Tacos and 2 blue iguanas, he's going to scratch his head for a long time because he's not really going to care which one between those two options. And so that's the case with any 2 options you would offer on here. He's indifferent. He doesn't care which one he gets. Okay, so every amount on this indifference curve provides a certain amount of utility. So I don't know, utility could equal 5 on this, however you measure utility. But any point on here gives them the same amount of utility. So I'm just putting that up there as a random number. That's not from the problem itself. I'm just kind of putting that up there. So it also says we're indifferent between 1 and 6 or 6 and 2. So I'll go ahead and graph those as well. So we're also indifferent from 1 and 6 right here, or 6 and different.
Okay, I'm back now. Sorry.
And so we're still in those 2 points as well. And so I could draw another curve down here. And we can see that the utility is less. It's closer to 0, which is right here. It's less than the curve right here. So utility there might be, just as a utility there might be 4. So we prefer to be anywhere along this last utility curve or indifference curve. And anywhere on there, we are indifferent between different points on the black. We're also indifferent between points in the group, but we're never going to. We'd always prefer the black curve. Why is that? We'd always prefer the black curve because we get we're offered more meals, right? We're offered 2 Del Tacos and 6 blue iguanas, whereas on the blue curve we're only offered 1 Del Taco. So it's kind of easier to think about if you put it into terms of like comparing one point on each curve. But when as this curve gets closer to 0, the utility is smaller. So you can just refer that way too. So if I was like way out here, this would be like a really fun curve to be on. You get a lot of utility. Yeah, you get like 10 meals, 8 meals. Yeah, it would be. Eventually, once you get this kind of meals, your marginal benefit will go down. But we don't know anything about them. Yeah, but that is, that's the law of marginal benefit. So, okay, so that was part B. So I guess I can just label these. So this is part A, and this is part B. Okay, so part C says You have $90 to spend on meals at Del Taco and Blue Iguana. Meals at Del Taco cost $6. I'm gonna write this down. Okay, so we have total $90. Del Taco costs $6, and Blue Iguana costs $18. Add the budget constraint to the graph. How many meals from Del Taco and Blue Iguana would you buy? Okay, so the way that we'd want to find this budget constraint curve now, which I'll draw in different colors, is by finding the 2 points of intersection on these different axes. That's the easiest way to do it. So we will do that by finding out if we spent all of our money on Blue Iguana meals, how many would $90 buy us? And then we'll do the same thing over here and find out how many Del Taco meals we could get with $50. Yeah, so over here, yeah, 5. So if we got only Del Taco meals, which are $6 a piece, so $90, our total money divided by how much a meal costs is 90 divided by 6, which is 15. So we could buy 15 Del Taco meals if we went all on Del Taco, or we could get Blue Iguana meals for $18. So we would do $90 divided by 18, and we would get 5. So here is our budget constraint endpoint, and after that we can disconnect it. I'm not sure if I drew my graph to scale or not, so I'm not sure if that's the true intersection point. Let me just look to the graph that he drew. Oh, that actually does look like it's the right one. Maybe. So it is supposed to intersect with that other curve. This one's on problem set 3, number 1. Okay, so after you've drawn your budget constraint, which is the green line, this is part C. After we've drawn that, we can figure out what the most optimal allocation is for us to buy between these 2 types of meals. So we want to, as you can see, this green line is intersecting both of these indifference curves. But we remember that this indifference curve is not as good as this indifference curve, right? So if we can get on a higher indifference curve, that's better. We want to get on the highest one possible. So you're going to keep moving out from this, from your 0 point, and get to whichever best indifference curve you can get to. Unfortunately, we can't get to these orange indifference curves that I just drew because they don't touch anywhere on our budget constraint. But we also don't want to choose any indifference curve like this blue one, where the budget constraint intersects twice with the indifference curve, because that indicates that you're not on the farthest one out yet. Whenever you're in the farthest indifference curve out, you will be on the indifference curve that only touches exactly one time with your budget. It'll be tangent to your budget constraint. So that's the case it looks like here, at least the way that I've drawn it. I mean, this isn't probably to scale perfectly, but from this example, it looks like the budget constraint intersects with this indifference curve, at this point. And so if that's the case, then that's the best, most optimal purchasing ratio for you to take.
Hey, Brittany, can I ask a question?
Sure.
So on this, and also on like the next one, D, where you add $10 to Del Taco's price, and your line intersects that one point on the indifference curve.
Uh-huh.
Is this where we just eyeball it and you say, yeah, that looks about 4 and 2.8 or whatever, or 6 and 3, or is this a hard, fast number?
So I think that you have to eyeball it
Yeah,
because we don't have the equation for the indifference curve lines. We could come up with equations for the budget constraint line because we have 2 points and it's a straight line, but
right.
we don't know the indifference curve equation is. And so you're right, we'd have to eyeball it. So I guess for these problems, it would be important to really try and draw it to scale so that you can kind of get a better idea.
Would you, if you were a betting woman, would you bet that this might appear on the test, or?
Yeah, I would bet that anything on a problem set could appear on the test. I don't remember, because it was like a year ago that I took this class. I don't remember if this specific question is or not, but I don't know. I would not be surprised at all if it were. Yeah, they would just be similar questions. They're not going to be the exact same as the problem set, so you'll need to understand. Yeah.
Is that John Morgan in the room?
Yeah, it is.
Well, he's faithful, huh?
Yeah, very devoted student.
John is a devoted student, yeah. Go John.
I think you're probably doing pretty good.
I think I'm just starting to get some concepts. Best I can skim through it. Right.
Yeah. Yeah, it is.
So the blue line,
This blue line, how to get this one?
where do you get the numbers for that?
This one came from part B of the question. So if you look in there, we got these 2 points. Okay, so let's see here. Part D, you just said, imagine the price of a meal at Del Taco increases to $10. Then we would have a different indifference curve, or a different budget constraint curve, or I guess it's not a curve, it's a line. And it would still be starting right here, because the price that we would want it has remained the same apparently. But now we can only afford to get 9 meals, because 9 divided by 10 is 9. So it looks like it intersects about right here. And so yeah, you would just eyeball it, Bryce. Looks like it's about 4 and 2.8 or 3, just like this, just like the slides say. I got lucky when I drew that pretty much to scale. Yeah. So he's the only one on the actual call, but we have 2 viewers, I think, on YouTube as well. So you viewers on YouTube, if you want, you can try and find the invitation that I sent to the phone call, and then you could join in and ask questions live too. So that's an option for you guys. Okay, so Bryce, was that your main question with this number 1 problem? Was just whether or not you're supposed to eyeball, or if there's a way of figuring out the exact number?
No, actually, on this, I actually missed the next 3, E, F, and G.
Oh, okay, so E, F, and G is what we need to do.
Yeah, so this one I got dominated on for whatever reason. I didn't put the answers in.
What is keep going? From the information in parts C and D, we know that our consumption of Del Taco meals has dropped from 6 to 4 for a total change of 2. And that's because here we intersected right here at the indifference curve, which was about 6 and about 6 Del Taco meals and 3 Blue Iguanas, and then we went down to 4 and about 2.8, roughly, just eyeballing it. So this is what they're referring to in that part of the question. Okay. Yeah. So it says, label how much of the change in the quantity of Del Taco meals is due to the income effect and how much is due to the substitution effect. So we know from the information from part C and D, we know that you go from getting this amount to this amount, part D, because of the price increase of $10.
So with that, so here's a question.
Yeah.
When it says change in the quantity of Del Taco meals, so the income effect is basically I get fewer Del Tacos because I'm effectively poor.
Yes.
Meaning I could have bought, if I had $90, I could have bought 15, but then it went up $10, so now I can only buy 9. So is that my answer? The change in income effect would be whatever that is, 6.
Okay, let me look.
15.
Okay. This is the first time I've seen this problem for a long time. Okay. Did it catch? Okay, so let's see here. So to come up with the, to describe the income effect, you would draw, we could think about it by drawing, I know what color I should use. You can think about the income effect by looking at the difference between part C and part D in your graph. And you went from this point to about this point. If this were just an income effect, then this whole line, C, our budget constraint, would have shifted down. And it would have intersected here, and it would have been parallel. See how this red line and that green line are parallel? So if it were just the income effect, then if we say we had now only $60, that would be an income effect, right? Our income goes down, we have less money to spend on Blue Iguanas, and as a result, we would have been able to get proportionally less Blue Iguanas and proportionally less less Del Tacos. So we would have had this decrease and this decrease. But if it were just a substitution effect, let's see here.
The income effect, though, I guess my question is, isn't the income effect even so I have $90, just the fact that Del Taco increased in price is income effect, right? Because I'm poor, I can afford less.
Yeah, your $90 can buy you less things now.
So that is income effect.
Yeah.
And then substitution effect. And so you're saying, so I show the answer here is 1.3 for substitution and 0.7 for income. I guess my question is, where did that 0.7 come from? Is that the difference between those two dots? Between the two indifference curves?
So hold on, let me look at I'm looking at the key right now, so let me see what it says. It says to calculate the income effect, you start from the original budget constraint, which is part C, the green line. And we want to isolate the income effect when we're looking at that one. So that would be a parallel shift, which is what I showed in the red line. Just a straight income effect would be a parallel shift. So I just drew a new constraint that was parallel to the original budget that was also tangent to that new indifference curve.
Got it.
And then since we haven't changed the slope of the line, we're just looking at the income effect. As we can see that if we had just moved the budget constraint in a parallel fashion, we would be tangent to the indifference curve at the point of about 5.3 Del Taco meals. Let me see. Which means that the income effect would be a change in 0.7 meals. So let me try and figure out where this 5.3 Del Taco meals came from. I'm not sure, to be honest. I'm looking at the slides and I just want to be honest with you guys. I'm not sure why it goes down from 6 in the part C to 5.3 in with just the income effect. But that's the number that he's giving. Apparently he thinks that if you change that parallel curve and shift it down, that you're going to end up about right here somehow. That's not a point that we have found it anyway, so I'm not sure. Well, I'm looking at his slides right now too, and so that is to proportion in the slides, I think. I'm not sure. So it says, with the income effect, the price ratio stays the same, which we've drawn, but you move to a new lower indifference curve, which we've also drawn that part. I mean, you can see that the red line intersects at a lower indifference curve. But for some reason, he thinks that it would intersect at 5.3, which I'm not sure why. I'm not sure why it doesn't intersect with the other point. So this is something I can take note of and go over with you guys in the next review session if you'd like. Yeah, so Del Taco is always in the X, blue one is always in the Y. And then what is that another for you? Yeah, that is another thing I didn't tell you, and that you just had to look at the slides to figure that part out. Okay, so the income effect essentially says you move down in equal proportion, you effectively are poor, so you can buy less of both. The substitution effect, because the price ratio between Del Taco and Blue Iguana is now different. If it were just a straight substitution effect, then this is the original line for your budget constraint. If it were just a substitution effect, you would just be shifting along. So you would be able to buy Yeah.
So the answer I got was 1.3 for substitution.
Yeah,
That makes sense how you spin it on how it pivots kind of.
yeah.
And how you can buy one or more and they substitute, right? But I don't get that 1.3 for the answer.
Not sure either about that, Bryce. I mean, it looks like he just eyeballed this again on the graph, but I'm not sure. So the thing I'm not sure about is why he moves. I'm not sure why he moves all of a sudden to 5.3, which is a number that we haven't seen at all. Like, we've looked at 4 and we've looked at 6 Del Tacos, but I'm not sure where the 5.3. So I can ask him that this week when I see him, and I will, so that I can talk to you guys about it, and then I can come in and talk to you guys about that on right before the test, because we're doing a little mini review session right then. Is that all right?
Yeah, that's fine. That's great.
Part F is what causes the income effect, and I think you're pretty clear on that one already. The price increase effectively makes you poorer because your money now buys less. And then what causes substitution effect? You're willing to buy more Blue Iguana meals now because Del Taco meals are relatively more expensive. So you'll substitute Blue Iguana for Del Taco. So part H says graph the demand for Del Taco meals. And what is this Satira's?
Yeah, I missed this one too.
And put the 2 on the first graph on this. Okay. Let's see how far over you guys can see. Oh, you can see all of that. Cool. Sure. Let's see here. So for the supply and demand, we do price and quantity, price. When the price is I'm doing part H, I think. Yeah. Okay. Mm-hmm. That's okay. So bundles are like, you know, by John just asked what a bundle is, just to review. So a bundle is just in the comment says bundle, and that just means the allocation of Blue Iguana Del Taco. So it's like your bundle. Okay. So let's see here. I've drawn the started out with a graph for price and quantity. Okay, so when Del Taco meals were $6, how many did we demand? We were at this point right here, right? That was the best point on that budget constraint line. When this is the budget constraint line when Del Taco meals were $6. So when there were $6, we wanted 6 of them. when they went up to $10, how many Del Taco meals did we want? We went down to this point, right? Yeah, so we wanted 4 on that when it was curve was there. Those are the only 2 lines of the points that we have, but that's enough to draw a line, right? So this is the demand for Del Taco. What's that?
That was on the original.
This one is on the original budget constraint, so this is from the line C, and this one is from line D after the price change.
Thanks for doing that. That makes sense. We didn't pick those numbers arbitrarily though, right? It says put 2 bundles that you chose on the first graph on this demand curve.
On
So,
for
I'm trying to remember if those weren't arbitrary numbers. Those were numbers we chose, right?
for which part are you looking at, Bryce? Which part of the problem?
Sorry, on H, the 10 and the 6.
Oh, those. So yeah, no, those aren't arbitrary numbers. Those are numbers that we pulled out of this. So I pulled the 6 and the 10 out of the 2 prices that the problem gave us. So
Okay, yeah, that makes sense. Okay.
when Del Taco was $6, line C was our curve, was our budget constraint curve, and that put us here at this point of purchasing. And then when the price went up to $10, we went to this point on line D.
Yeah, that makes sense. Okay.
Cool.
Well, thanks for taking the time to do that. I've got to go walk precincts for a campaign that I'm part of, but I appreciate your help with this.
No problem. Thanks. Thanks
Thank
for coming.
you.
Mm-hmm.
You bet. We'll see.
Bye. Oh, wow. Cool. Okay, so it seems like that was the part that Bryce wanted me to go over, was just the parts that I've already gone over. If we wanted to go over part I now, we would just use the supply and demand curve that we just created. Or no, we didn't do supply and demand, we just did demand. And we would just use your formula, right? The price elasticity formula, which is the change in quantity over the change in price. Yeah. Or percent change in quantity, or percent change in price, rather. Yeah. Okay, so that's what I've got so far for questions. Let me see if anyone has added anything to the Excel sheet. Doesn't look like it, so I'm going. So someone has asked how to join the Google Hangout session. I sent out an invitation, and I'm not sure how those invitations got to you guys. I think they usually send to your email, but if you don't have a Google email, that might be the problem. I know that was sometimes a problem when we were doing the Hangouts before. Otherwise, you can email your question if you'd like. I'm not sure who wrote that in there either. Okay, I'm going to go ahead and take a question, John, if you have one, John. You want to go over some elasticity problems? Okay, what problems do you see those in? We can do the elasticity of this one too if you want. That's problem set 3 as well. No, pizza movie one. Oh, it is. Okay. Okay, so John would like to go over. Is that the one you want to go over first? Okay. So John would like to go over problem set 3, same problem set number 2, which is the pizza and movies question. So I'll give you guys a chance to get there. It says you can spend $24 on fun. That's your budget. Pizza costs $6. Movie rentals cost $3. What is the formula for the rational spending rule? Give the formula and explain it in your own words. So the formula is that the marginal utility should be so spending should be allocated across those two goods. You should spend your money on pizza and movie rentals so that the marginal utility per dollar is the same for each good. So this marginal utility of pizza over the price of pizza is the same as marginal utility of movies to the dollar cost. Because that's when your marginal utility per dollar will be maximized. Okay. So graph your budget constraint. Movies on the x-axis. Okay. So movies and pizza. So we have $24 for budget. How much is pizza? Pizza is $6, movies are $3. We can get 4 pizzas if we spend all of our money on pizzas, or we can get 8 movies if we spend all of our money on movies. So there's our there is our budget constraint line. Okay, given how much utility you get from pizza and movies, which is given, I'm moving on to part C, guys. So this is how much utility you get from pizza and movies in the table below. Now we should calculate our average and marginal utility from different amounts of pizza in movies. I wish there was a faster way to do this. Yeah, I have to like draw this table out every time. Okay. Okay, so we have pizza slices. Total utility. Average utility. Marginal utility. I need more room. I'll just do like the first two. Okay. So I'm just gonna do the first two, guys. I'm not gonna fill in the entire table. I'm just gonna show you how to do it. Okay, so we have people slices, total utility, average utility, marginal utility. Total, average, and marginal. Okay. So when we buy 0 pizza slices, we get 0 utility from that. Our average utility is 0, etc. We get 0 movie rental, 0 utility, 0, 0, 0. When we buy 1 slice of pizza, it says that we get a total utility of 20, which means that our average utility is 20, because 20 divided by 1 is 20. So I just filled that in for you guys. And then the marginal utility, going from 0 to 20, is 20. Right there. So on your first piece of pizza, your marginal utility is going to be the same as your average utility and your total utility. Because your marginal utility is your additional utility that you're getting out of buying that one extra piece of pizza, right? And you go from 0 to 20. So your extra utility is 20. For 2 pizza slices, it says you get 36 utils out of that, which makes your average utility 36 divided by 2. So on average, you're getting about 18 utility per slice of pizza. And our marginal utility is going to be the difference between 36 and 20. So we had 20 utils before. By buying an extra piece of pizza, we go to 36. So that means the additional utility we gained was 16. Is it showing that? Yeah, it is clearer because it shows that when you go from 0 to 1, it's 20. Whereas if I put it up at 0, you wouldn't know if that was going. If I put it right here, for instance, you wouldn't know if that was going. Is that going from 0 to 1, or is that going from 1 to 2? Yeah, that's right. I'm going to do one more. So 3, it says we get utility of 48. So our average utility is going to be 48 divided by 3, which is 14.5. And our marginal utility is going to be the difference between 36 and 48, which is 12. You went from having 36 total utility to 48. So the extra that you get, or the marginal, 12, for buying one more piece. Okay, so for movie rentals now, the first one we get a utility of 40. Okay. Oh. So our average utility then is 40 there, and the marginal utility going from 0 to 1 is 40. Love that first movie. So the numbers that he chose and he gave you, okay, those were, yeah, numbers that he chose. Yeah, decided that that's well, in real life, it is based in that is like something you take into consideration, probably, but yeah. So the next movie that you would buy, your total utility goes up to 46, which means your average utility goes down to 23, and your marginal utility goes from, you get a total of 40 to a total of 46, so you get 6 additional utilities. Then you go up from 2 movies to 3 movies. Your utility goes up 50, which means that your average utility is going to be 50 divided by 3 is 16.7. And your marginal utility goes up from 46 to 50, so only 4. Your marginal utility really starts to drop off after that, right? Okay, so there are, I can do more numbers than that, but I am not going to. The less each one. Mm-hmm. Until eventually you stop eating turkey, right? Mm-hmm. Okay, so next part of the question is part D. How much pizza and how many movies should you buy? So we have $24, and remember that so we have $24 total. Pizza was 6, and movies were only half as much. Which is saying basically that even if movies don't provide you the same amount of utility as pizza, you still might want to buy a movie because it's cheaper. Because for $1, you might be getting the same amount of utility. Okay, so we have $24 to spend. The first thing that we're going to buy is going to be a movie, right? Because we get 40 utility from buying our first movie. So that takes us from $24 to $21. I'm just going to do it like this. So pizza, movies. Okay, so we're going to buy a movie, one movie, and that takes us down to $21. Okay, what are we going to do next? Are we going to want, we still haven't bought any pizza, so we're still looking at this marginal utility. But over here now, we're either looking to get another movie, which is 6 utility points more, or a slice of pizza, which is 20 marginal utility. So you want to consider the amount of utility that you're going up. I forgot to tell you guys that. But you also want to consider how much utility per dollar. So if it were the case, for instance, that this were 10, then we'd be getting 10 utility out of $3, which would be the exact same as getting 20 utility out of $6, right? So in this case, we are going to buy the pizza because 20 divided by 6 is greater than 6 divided by 3, right? So we'll get 1 slice of pizza, which brings us down to $15. Okay. Next, what we're going to do? We're going to look at, so pizza is 16 for marginal utility, or so we can get a second slice of pizza or a second movie. Here, our marginal utility is going to be 6 divided by the cost of the movie, which is $3. So marginal utility per dollar is 2. Over here would be $16, and the marginal utility divided by 6, which is a little bit greater than 2, right? So we're going to buy another slice of pizza. I'm just going to tally. Or maybe I'll just do which takes us down another $6. So we're at $9 now. But you would keep doing this until you run out of money. So we bought 2 slices of pizza. We bought this, and we bought this, and we bought this. Okay. Next, we're going to look at this versus this. Okay, so you can get 6 utility points for $3, or 2 per dollar, or we can get 12 for $6, which is 2 per dollar as well, right? It doesn't make a difference for that one. Yeah, one or the other. And since we have enough to get one more of each, we'll probably end up getting another pizza and another movie, right? We have $9 left. So this will be 3 and 2. We end up buying this. So you want to consider how much your marginal utility is going up, but you want to make sure that you're considering that as a ratio to price. Remember that formula that we wrote. So that's how you would do these problems.
And then test.
Yeah. 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 I think so. I've done that before in tests where I'm like, okay, I have this formula in my head right now. I'm going to write it down and then also go through the problems afterwards and use those formulas. So that's one thing you can do. Okay, so that's number 2 then. Let me see. Let me look at that now. I've got to go just a little bit before 10 today, guys, because I have a meeting at 10. Seems like people like to go over marginal cost and marginal, like, you know, the average marginal, all those things. Yeah, we can do elasticity. Is that which problems is that? Or number 3 then. For this purpose? To be honest, I just bought the most inexpensive computer. This is a Lenovo. Yeah, well, it's not the least expensive, but it had really good reviews. I got mine from on like Black Friday last year. Yeah. Okay, so you want to go over number 3 real quick? Okay. So we live near the BYU football stadium. Your 10-year-old daughter wants to sell lemonade before the game to make money. She decides to charge 50 cents per cup. You happen to know that she faces a certain demand curve, which is given. So graph it. We'll graph it. Okay. Okay, so the demand curve is so when P equals 0, quantity is 90. Okay, so we have a point here. When P equals 0, Q is 90. When Q equals 0, what is E going to be? It's going to be 0 equals 90 minus 60. So 60 equals 90. So E equals 3. Right? Okay, so that's the demand curve that she faces. We also know that right now she has the price set at 50 cents. This is where her price is right now. How many cups will she sell? Okay. We know that the price is 50 cents. We want to know what the quantity is. So we're going to plug in that price to our formula to find out what exactly this place is right here. So we're going to do 90 minus 60 times 50 cents. So 90 minus 60 times 1/2 is 30. So she's selling a quantity of 60 right there. Right? So that's part B, how many she's going to sell. What will her revenue be? It'll be quantity times the price. So the area of this is her revenue. So 60 times 0.5, so her revenue is going to be 30. That makes sense? So revenue equals 60 times 5 equals 30. Okay, what is the elasticity of demand at the point where she will be selling? So in order to come up with elasticity of demand, we need 2 points. Right now we have this 1 point. Because, okay, so the formula for this is change in quantity over quantity over change in price over. So this is the formula we're going to use.
That's just a basic.
Yeah. So sometimes it changes the quantity of which thing. Price elasticity of the substitute or something. Yeah. Okay, so
The price, it's always a powerful
I don't remember. So we have this point right here, which is 60 negative 0.5. We have 1 point, but we need another point. You just choose another point since one isn't given to us. If one were given to us, we would use that point. But not. So an easy point would be one of these two endpoints because we already know them. Right? You know, this is 60, 0, and 0, 1.5. So I'm just going to choose 0, 1.5 because that's the problem on the example. So I'm going to treat this like it's 0.1 and this like it's the second point. Okay? So for the purpose of the, yeah, so we're going to do price 1 minus price, or sorry, quantity 1 minus quantity 2. So it'll be 60 minus 0 over 60. Yeah. And then so that's going to equal 1. And then I'm going to do the price one, we have to do it in the same order. So if this is quantity one, this is going to be price one. So price one, 0.5 minus, oh yeah, wait, what did I do? Oh yeah, so minus 1.5. So this is the price of yours. So this is going to be negative 1 and then over original price, 0.5. So we end up getting, yeah, we get negative 1 up here divided by 1 half equals negative 2. So the price elasticity of demand is negative 1 half. That means that the percentage change in quantity, which is what this number is a smaller in proportion to the percentage change in price. So quantity changes faster than price, right? So what does that mean? It means it's elastic, right?
It's below one, it's inelastic.
If it's below one, it's inelastic. Oh yeah, sorry, it's inelastic. I think I said it wrong. So the price changes faster than the quantity. Yeah, because you can change the price and quantity won't catch up to it very fast. And if you raise the price, the quantity is only going to go up. Yeah, it's only going to go down a little bit. So that's how that is. Probably I might be able to do per E. Mm-hmm. Okay. So she goes up to right here. That's her new point, right? And we want to know what her new quantity is. So we plug it in over here at the point 1. We would get 90 minus 90. So this is the quantity, and then to get revenue, 45.75.
You got that, so
So this would be 33.75. 4 was 30. So her quantity decrease. The quantity decreases, revenue increases. I can actually stay a little bit longer because the person that I'm meeting with is running a little bit late. Yeah, yeah, same concept.
So here, so that's TPS, so bus traffic.
So I'm not going to tell you what strategy to adopt, but I'll tell you this. You know, Dr. Turley has told you that test is going to take more time than you have.
Yeah.
So you know you're not going to finish every problem on the test. And if it's the case then that you know how to do 75% of the problems that you're going to get on the test very well, then you can choose those you can choose those problems to do on the test. What I don't know is whether or not those later problem set problems, because problems in the test have different point allocations to them. So it would be a bummer if you went on the test and found out that one of the big point problems, like maybe a 20-point problem, was a problem set problem that you didn't know as well. Because then even if you do finish 75% of the test, you might not be getting, yeah. So that's kind of that's my thinking on it. Well, I don't know, it depends, because so kind of goes back to the marginal utility per dollar, because you'll look at the marginal utility of a problem per minute that you have. So the longer problems are worth more points, but they're also take longer time.
Would you get partial credit for partially?
Yeah, yeah. Mm-hmm.
So he did partial.
Yeah, I think he gets partial, if I recall correctly. Mm-hmm.
So you do it Tuesday.
I'll do it on Tuesday, and then I'll do a little review session on Thursday. Mm-hmm. Yeah. The review session is going to be for 50 minutes, I think, and then the test is going to be for 70. Okay, guys, so I'm going to head off to my meeting now. On Tuesday, we're going to do the same kind of layout for office hours. I'm just going to offer you guys to keep filling in that same Excel sheet that same Google spreadsheet that I sent you with problems that you'd like to go over. I will also be sending out another invitation, just like this time, to actually join this call. So if you'd like to get in on that, you can maybe contact one of your friends who has done better with that, and ask them how they where they received their invitation and how they did that. And then, of course, if you need me to send the invitation to another email next week, just let me know and I'll add that email. So yeah, look over your problem sets this week as you're reviewing for your midterm, and look at what you'd like to go over, and then I can go over that in just whatever order I get the request then. So thanks, guys. See you Tuesday.